What if we are not the creators of our universe, but artificial creations completely unaware of our true nature? It is unsettling to consider, but we may not be real, and we might not even know it. Your immediate thought is probably that our current understanding of physics makes it impossible to simulate the entire universe. There are simply too many trillions of interacting parts. But a highly advanced system wouldn't actually need to render billions of galaxies. It only needs to generate enough of the universe to fool its inhabitants. The vast expanse of deep space could just be a flat projection, because the simulation only renders the exact spaces we are allowed to explore. The same rule applies to the microscopic level. The chair you are sitting on right now does not need to be calculated down to the quadrillions of atoms. A simulation could just render the outermost layer, leaving the inside completely empty until you physically break it open to investigate. Even the cells you look at through a microscope could simply be generated the instant you look through the lens. When you strip away the massive scale of the cosmos and the tiny details of atomic physics, the absolute minimum requirement to build a simulated universe becomes much simpler. You don't have to perfectly render physical reality. You only need to fool human consciousness into believing it's real. To figure out if this is actually happening to us, we can look at a modified version of the simulation argument, originally proposed by philosopher Nick Ostrom. It lays out 5 sequential assumptions. Assumption 1 is that simulating consciousness is theoretically possible. While we don't fully understand consciousness itself, we can assume it could be generated by replicating a biological brain. But human brains are intensely complex. Counting the interactions between synapses, a single brain runs at about 100 million billion operations per second. This chart illustrates the terrifying computational load of that assumption. Generously, a computer would need 10 to the power of 20 operations just to simulate a single second of human consciousness. But to simulate 200 billion humans over an average lifespan of 50 years, effectively rendering all of human history at once, you would need a machine capable of 1,000,000 trillion operations per second. That is more operations than there are stars in the observable universe. This brings us to assumption 2. Technological progress will not stop. If development continues as it has, eventual galaxy-spanning civilizations will reach technology levels so advanced they appear godlike. They could build theoretical megastructures, like the Matryoshka brain, to achieve this exact computing power. A Matryoshka brain is a massive framework made up of billions of parts orbiting a star. It feeds directly on the star's radiation, harvesting the raw, monstrous energy of solar flares and surface heat to run operations. A machine of this scale would easily have enough power to simulate millions of humanities at the exact same time. Whether it takes the form of a star-swallowing megastructure or a highly advanced quantum computer, computing power is a solvable engineering problem. Given enough time, the physical hardware required to run our reality will inevitably exist. But having the blueprints for a universal computer doesn't mean it ever gets built. Assumption 3 states that advanced civilizations don't destroy themselves first. As we look into space, we expect to see millions of alien civilizations, yet we see nobody. This points to the concept of great filters, extinction barriers like nuclear war, massive asteroid impacts, or global climate collapse. If life is inherently self-destructive, nobody survives long enough to press power on a simulation. Even if a civilization successfully navigates every great filter and becomes a post-human society, Assumption 4 requires that they actually want to run simulations. We cannot project human motivations onto beings this advanced. Imagine trying to explain the concept of roller coasters, holidays, and waiting in line at an amusement park to the smartest ant on Earth. It simply wouldn't make sense to an ant living an ant life. Compared to a post-human civilization, we are the ants. Dedicating unlimited energy to simulate history might seem like an absurd, pointless idea to them. However, if a civilization does avoid extinction, and they do harbor an interest in running historical simulations for science or entertainment, then the creation of digital realities becomes a mathematical viability, which leads to Assumption 5. If these civilizations have access to practically unlimited computing power, they wouldn't stop at building just one simulation. it would be trivial to run millions or even billions of them simultaneously. Starting with one base reality, if it runs billions of simulated universes, the original population is rapidly engulfed by trillions of simulated beings. Since you cannot physically test your reality, probability shows that for every biological human, 1 billion simulated versions exist. The odds of you being the one biological human out of 999,999,999 simulated ones are virtually zero. Based on the math, what you consider to be physical reality is almost certainly a simulation. Of course, all of this relies on assumptions that we can't test right now. Many scientists completely disagree with the thought experiment. So please, do not burn your house down just to see if the physics engine glitches. If you are simulated, very little actually changes for you day to day. Whether you are living on a rock speeding through an eternal void, or processing lines of code inside a post-human computer, your existence doesn't become any less bizarre or any less real to you. All we can hope to do is try to live good lives, have a good time, and appreciate the reality we get to experience. And just hope that if we are running on a supercomputer somewhere, nobody accidentally trips over the power cable.